Okay, I know what you all are thinking right now. You are all thinking, I really like this product and quotient rule. It's pretty slick. But how will it help me with my tangent lines? Well, here we are. We're going to write the equation of a tangent line. So we want to write the equation of the tangent line of this function at the point 2, 3. So, of course, remember when we write the equation of a tangent line, the first thing we need is a point. And we're given the point as 2, 3. Next, we need the slope. Well, the slope requires our derivative. So let's go ahead and talk about how we get the derivative of our function right here. This is a division, so we have a top function, f of x, and we do have a bottom function, g of x. So this is our quotient rule. And if you remember the quotient rule, remember the derivative rule is, I say it's low d high minus high d low all over low low. So in other words, it's the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom function squared. So when we look at our derivative here, we would get f prime of x equals low, which is our x minus 1. The derivative of the top is 1 minus the top function x plus 1 times the derivative of the bottom, which is also 1, all over the bottom squared. Now your pre-cal teacher would be like, you better simplify this. Well, we don't really need to here, because to get the slope, remember, everywhere there's an x, we're just going to plug in a 2. And hopefully we can do most of this in our head, right? So if I plug in a 2, and the reason why I choose a 2, because I'm looking for the slope at x equals 2. That's my x value at 2. And if I plug in 2 for the first one, we can get 1, 2 minus 1 is 1, times 1, minus 2 plus 1 is 3 times 1, all over 2 minus 1 squared. And if you clean all of this up, you get the number 2. So there's our slope. So the equation of our tangent line then, don't forget we can use point slope, y minus y1 equals mx minus x1. So we would get y minus 3 equals 2 x minus 2. And there's our tangent line. Very easy to do. So how would I point this out in homework? You'd probably get 2 points for the derivative, 1 point for the slope, and 1 point for your answer. So a question like this could be worth maybe 4 points for a test or a quiz. Okay, the next one, I go, oh no, look, find another equation of a tangent line. Man, we really like these tangent lines. But this time, notice, we are multiplying two functions. Sine times sine x plus cosine x. This is going to be our product rule. Now you have two options here. One, you can distribute the sine of x, but that gets a little more complicated. So I'm not going to worry about distributing. I just want to get a derivative later on. So I'm not going to worry too much about that. Alright, so the first thing we need, a point, and they give us the point pi over 4, 1. Uh-oh. The 11th commandment, know thy trigs, right? Moses came down the mountain, right? Know thy trigs. That one didn't survive, though. Next, we do need to get our slope. So to get our slope, we're going to use our derivative rule. And this one's going to be a long one. So I'm going to take my first function, which is sine of x, multiply that by the derivative of the second. Derivative of sine is cosine of x, plus the derivative of cosine of x is minus sine x. So it becomes a minus because a plus, that's really negative, and the two signs make, the plus and the minus make us negative sign. Plus the second function, sine of x plus cosine of x, times the derivative of our sine of x, which is cosine of x. And again, I don't have to worry about cleaning any of this up, because to get our slope, we're going to plug in the x value at pi over 4. Now again, whoops, there we go. I'm going to put pi over 2. So we're just going to plug in pi over 4, and I'm just going to do what I know. The sine of pi over 4 is root 2 over 2. We always use radians in here. So notice what we're doing with radians. So make sure you know those. If you need to convert to 45, it's okay for now, but you eventually want to know your radian measures. Now, cosine of pi over 4 is also root 2 over 2 minus root 2 over 2. We gotta know what that is. Oh, look, all that's just 0. How nice is that? Plus, sine is root 2 over 2, plus cosine again is root 2 over 2, times root 2 over 2. Well, we already know that that's just all how that term is just 0. So therefore, to get our slope, I'm going to take root 2 over 2 times root 2 over 2, which is just, what does that become? Just, well, if I have half of a root 2 plus half of root 2, that's just going to leave me with root 2. Or if you want to do 2 root 2 over 2, you're fine as well. Multiply that by root 2 over 2, and notice what we get. The number 1. The slope there is 1. So therefore, my tangent line, y minus 1 equals my slope, which is 1, x minus pi over 4. And remember, we leave it in this form right there. We don't try to change that one single bit. Tangent lines are one really good way to use our derivatives, but another one, more of an application, is to find horizontal tangents. We talked in my last videos series that the tangent is where the slope is 0. And we have a very special name for these. We call them critical numbers. Okay, these are very special numbers for us, called critical numbers. So the first thing we're going to need, of course, is our derivative. Now, this is not a hard derivative. This is not our product rule or quotient rule. So this is just our basic power rule. We would get 3x squared minus 2x. And we set that derivative equal to 0. Now, I'm going to do a little bit of algebra. You can do your algebra first here. I'm going to just go ahead and write it out. I can factor out an x, and I would get 3x minus 2. And so my critical numbers are x equals 0 and x equals 2/3. These are what we call our critical numbers. In other words, what we're going to find out later on, this is where the slope possibly changes, goes from up to down or from down to up. It doesn't ask for this, but let's see if we can kind of take a look at kind of what this looks like right here. Now, we know that this is an odd positive function. And you might remember from your pre-cal, odd positives have in behavior, the left side is going down and the right side is going up. So it looks kind of like a cubic graph. So let's see if we can use that to kind of figure out what this graph looks like. Well, this says we have a critical number or horizontal tangent at somewhere at 0. I don't know exactly where this is. I mean, I guess I could have plugged it in 0, 0. So there we go. 0, 0. And we have another critical number at 2/3. So here's x equals 2/3. So because I know these are critical numbers and I know the basic shape, I know the graph goes up. That's a critical number, goes down, and at 2/3 it has to come back around again because these are where the slopes are 0. I know this because I know the basic shape of any cubic graph. We're going to talk a lot about these in the next month or so, over the next month or so. And another question they don't ask us is, well, where are the points? Where are those points at? In other words, what is my y values? So anytime they say a point, you need x and y. And this is very important, okay? Because if they say the word points, you need to have both x and y. So the first one we have is x equals 0. Well, if I plug x equals 0 into my function, so to get y, I'm going to use my function, f of x. So I would find f of 0, 0 cubed minus 0 squared, which is 0. So we have 0, 0. There's the graph right there. And if I want to find f of 2/3, okay, this is where the fun begins. We would get 2/3 cubed minus 2/3 squared. Now we kind of cheat, we don't simplify much in math. This becomes 8/27 minus 4/9. So we would have the point 2/3, 8/27 minus 4/9 for a point. We don't simplify, we just leave it alone for now. And later on we're going to describe this. This is called what's called a local minimum, and up here is what we call a local maximum. Kind of cool for us to work with. That's a lot more work than what this is. I wasn't asking for any of this stuff, but just to kind of show you what you're looking at. Alright, now the next one does talk about the need to find a horizontal tangent. And We're going to go ahead and do that one in our next video. So please go to video number 2 and take a look at this. Bye-bye.